Hello and welcome back. In this session, we are going to learn maximum distance in arrays. Okay, here is the problem statement. Let me just maximize it a little bit so that we can read. Okay, here is the problem statement. Given m arrays, so, uh, there are many arrays. Obviously, it's not just single array. And each array is sorted in ascending order, so that's also given. That makes life very easy. Pick up two integers from two different arrays so that distance between them is the maximum of all such possible combinations. Okay, so we're picking numbers from different arrays. Okay, it's not from the same array. If it's the same array, it's sorted. Last element minus first element would give the maximum distance. Okay, but that's not the case. We have to pick from the different, and not only that, we have to find the maximum because there will be so many different combinations. Out of that, we have to find the maximum. But the good thing is, in each of those sub arrays, the minimum element is the first element and the maximum element is the last element. So we just need to find the global minimum. Sorry, global minimum is useful, and then we need to find the difference between global maximum and the global minimum. So that will be our answer. And the distance between two integers a and b is defined as the absolute difference. Okay, it doesn't matter whether positive or negative, we just need a distance. Okay, so here's the sample input, line number 4 to line number 8 over here. Over here up to this point. First sub array 4 5 6, second one 8 9, and then third one 1 2 3. So obviously it's a small array and it's fairly quick using some visual inspection. So the smallest element uh, in the first index is on the third array, and then the largest one is on the second array. Okay, so 9 minus 1 8 is our answer, but we need to write algorithm everything and then do the do the full implementation. Okay, now we are going to, how this is going to work is, well, we'll write the we let's just quickly kind of walk through it. So how we are going to do is the quick algorithm is, initially we assign result our final result 0, and the minimum value, we get that minimum value uh, from the first element of the first array, and the maximum value from the last element of the last element of the first array. Okay, so that's our initial minimum and maximum, and then we're going to compare them with minimum and maximum of the next array and so on. Okay, and then in each iteration, whichever is for minimum, whichever is minimum, we keep the minimum. For maximum, whichever is maximum, we keep the maximum. Okay, fairly straightforward. So we loop through the length of the external array. In this case is 3, and then in result we get the maximum of the current value of the result, and then the maximum of absolute value of uh, the difference between last element and the mean value, and absolute of difference between max value and the last element of the current array. Okay, so we're getting one more time, result is the max of current result. If the current result is greater than the whatever max we are going to get, we keep the current result. Otherwise we get the max of two things. One is the difference between uh, last element and the mean value, last element of the current array, current sub array, and the mean value. Another is the difference between the max value and the first element. Okay, and we have to take absolute, we take the absolute, and then whichever is maximum in these two, we take the maximum value and assign that to the result. We continue this for the entire external array's length, and then in its iteration, our mean value is the minimum of the current minimum value and the first element of the current array. Okay, that's minimum. Whichever is minimum, we just get the new minimum, and then max value is the max value, and then the last element of the current current subarray, okay, whichever iteration we are in. Okay, so yeah, and then that's it. It does the implementation. So now in terms of complexity, time complexity, we, as written here, we traverse only once, so that's why it is order of n. Okay, and then in terms of space, in fact, we, let's see, we don't have additional storage here. Actually, it's the order of one, is a constant space. Okay, if you have like a, you could say, result, mean value, max value, this kind of things here, you have a very fixed amount of storage, additional storage required. So it's order of one for the space complexity. And I have in the last two lines, I have already made some value for Java. First one is for Java, second one is Python. Let's get started in Java first. All right, we are here. I'm going to minimize this and we're going to cruise. Okay, vi max dist in arrays for Java. Let's set number as well. Okay, class max dist in arrays. Okay, and public static void main string args. Okay, and we'll come back here. Now first we do our main method implementation, and we'll name it return type is obviously one single value, the maximum value. We'll name it max distance, and we're going to supply two-dimensional array. It's an array, and then inside we have sub arrays, right? It's an array of arrays. Nums, let's call them nums because they all are numbers. In the arrays, that's it. Int result is equal to 0. Let's not forget semicolon. Int mean value is equal to nums 0 0. That's the first element, our initial minimum value, and that should be integer. Our max value, initial max value, is the last number of the first subarray. Okay, and that is, we compute that by nums 0 is length and minus 1 because index starts from 0. Okay, so the last index is going to be length minus 1. That's it. Okay, so now we look through our external array, and I is equal to 0 is less than nums dot length. Yeah, then I plus plus this one over here. Okay, not exactly. Okay, all right, that's the right tab. Okay, result, you write this line. This is the most important line here. Math.max, maximum of two things. Okay, result, current value of result, or whichever is the maximum. And there we are taking one more maximum. It's pretty interesting. Max, there are two things. One is the difference between the last element of the current array and the mean value. Let's code that. How do we do this? And we need to get the absolute value because it could be negative, right? Nums I and nums i's length. Okay, minus 1 minus mean value minus minimum value. Okay, that's one, and we need one more. Math dot absolute now is the difference between max value and the minimum element, and minimum element is the first element of the current array, and the first element is 0. Okay, and how many brackets we need? Probably that's right. Okay, we'll leave this long line over there. Actually, I think it's not be a problem if we, let's see which is the good breaking point. I think this might be the good breaking point here. See result, and math max of that, and remember this one, right? Right, I'm going to that's the last one. Okay, yeah, so yeah, we are taking maximum of these two. Okay, the last element minus the mean value, or the max value minus the current max value minus the first element of the current array. Okay, it's very simple, only the expression is a little bit longer, and then in each iteration our mean value is equal to math dot mean current mean value, whichever is minimum, or the norms first element, because first element is sorted, so first element ascending order, so first element is going to have the lowest value. And similarly max value, probably now you might have already guessed, math dot max, and that's going to be max value, but this is going to be the last element. Okay, norms I, how do you get last element for that particular array? Norms I length minus 1. That's it. Come out of this. Okay, we don't need that. It's a line. Return the result. That's it. Okay, and that's for this method. Now we need to complete this one. Okay, and if you remember, I have this one ready just to save our time. Okay, now my result is equal to, this is static method, so I'm just going to, I can just do this one, max distance, and I'm going to pass my nums, and I'm going to print. Okay, dot out dot println simple my result. Okay, all right, save it, and we're going to compile it and see how many errors we get and fix them, and we'll run them. How many? Oh, lots. My result, result colon 5 system out print. Anyway, private static int max distance int enum expected 10, enum expected int mean value tuk int is equal size less than nums. Ready? No problem. We're going to fix it. Okay, what's the issue? Public static void main. Okay, I think that sounds right. Int my nums int my result equal max distance nums. I'm passing my nums and I'm printing my result. I think that looks right. Public static int, yeah, int nums. Okay, int result is equal to 0, int mean value is equal to nums 0 0, int max value is equal to nums 0 nums 0 length. I think that also looks right. This one also looks right to me. Hmm. Yeah, let's continue for I, result math, max, result, max, math absolute, of, is to reference, that num length minus 1. Okay, that, oh, last one. Yeah, Java needs semicolon. That's one thing we found. I think other places, well, let's compile it because it's supposed to reduce the error value, min value. Okay, here's the first one. Class interface are enum expected, private static int. Okay, class, well, we have a class here. Yeah, and publish static void MAINST. Oh, big time over here. We need 3 dots there. Okay, and all that is making huge difference. See, now we have only one, and now it's straightforward, as we can see that there are uppercases. Whatever was the line number, we need only high. We need only, see it. Now it might just compile because I think we fixed all of them. Oh, we're not getting, oh, we need to run this. We compile it, no error. I was too excited. Okay, now if it's right, it should print the result. That's it, and our expected result is also 8 over here in line number 10. Exactly. Right, so we're done with the Java implementation. In the next video we will implement in Python.